Hi everyone, this is Sushant. So guys, welcome to our today's session in which we are going to learn about cache scope in Mule 4. Okay, so guys, let's get started. So guys, these are the list of topics which we are going to cover as a part of cache scope in Mule 4. Okay, first we will understand what is caching, and then what is cache scope, caching process, caching strategy, filters, and cache scope demo. Okay, so first we will understand some few definitions, theoretical part, and then we will move to the POCs which I have designed in my Anypoint Studio to get more familiarity with the concept. Okay, so guys, let's get started with the first point. What is caching basically? So guys, from the definition it is written, caching is a mechanism to improve the performance of any type of application. Technically, caching is a process of storing and accessing data from a cache memory. Okay, so guys, what is cache? Basically, a cache is a software or hardware component that aims at storing data so that future requests for the same data can be served faster. So guys, from this diagram you will get some more clarity. Okay, so you can see same user is requesting his personal data from the this device, and next time again it is requesting this server, and again it is requesting this server. Okay, when there is no caching, so in that case, whatever request it will do in the first time, it will hit the server, get the response, it will get his personal details. In next time he will again request that server to fetch the personal details. It will again call that server will process his request and send the data. Third time again it will call that server to fetch the personal details, and again that server will look at the request and send the same data to the user. Okay, so guys, this is a case when there is no caching. There is no cache memory in which that user data is stored. Okay, so every time a user hits the server, that server will look at the request and process that request and send the data to the user. Next time again it will hit the server, again it will process, again it will send the data to the user. So you can see the same request is being processed multiple times by the server. Okay, it means like the server is having a high load. It means for the same request the server needs to process 3 times. Okay, so if let's say that server has configured some caching strategies. Okay, so in this diagram you can see a user requested first time to fetch the personal details from the server. So in that server, okay, a user data has been stored in the cache memory, any specific data which determines that particular user uniquely. So next time if that user will request that same data, that server will not process that request because that data is already stored in the cache memory. So doing so, that processing power will be less. There is like, because that data is already stored in the cache memory, so it will pick that data from the cache memory and send it to the user. And as a result, server not need to process that whole request again and again. And as a result, load will get reduced on that particular server. Okay, so next time that if that user requests the same data from the server will pick that data from the cache memory and send it to the user. Again, the third time also it will do the same. So guys, as a result, the load is reduced on the server. Okay, because it is receiving the duplicate requests again and again. So it doesn't make any sense to process a duplicate request, okay, and send that same data again and again. So that's how this caching helps, guys. Okay, so duplicate requests, okay, same data can be served faster, okay, with the help of caching mechanism. Okay guys, so guys, let's move on to the next topic, which is the main topic which we are focusing on, that what is cache scope. Okay, we used to configure cache scope in Mulesoft. Okay, so guys, we will understand what is cache scope. So guys, from the definition it is written, the cache scope is used for storing and reusing frequently called data. You can reuse a cache scope to reduce the processing load on the Mule instance and to increase the speed of a message processing within the flow. So guys, that's the same thing which I showed you previously in the diagram. So if you're getting some duplicate requests and you have configured some caching strategies over some of the components which are calling some server, so in that case you not need to call that same request again and again if you are getting duplicate requests from the input. Okay, so you can just reuse that same data and pick it from the cache memory and send it to the user without hitting the server. So how to configure that this cache scope I will show you in the Anypoint Studio, guys. Okay, for now I'm just letting you familiar with all these theoretical part. Once this done, I'll go to the POCs which I have created and make you familiar with all this concept. You will get more idea on this there. Okay, so guys, the next question is how it works, how this cache scope works. Okay, so guys, here it is written: when a message processor in a Mule app sends a message to a cache scope, the parent flow expects an output. Okay, the cache scope processes the message payload, delivers the output to the parent flow, and saves the output. That is, cache is the response. It saves that output in the cache memory. Okay, and the next time the cache scope receives the same kind of message payload, then it will pick that data from the cache memory and send it to the user without hitting that server again and again, without doing that time consuming process again and again, guys. So that's how it works, guys. Let's move on to the next topic. Okay, so guys, these are the points which are showing how this caching mechanism works in Mule 4. Okay, so guys, the first point saying the message enters the cache scope. You can see a message is entering from here. Okay, when a flow is triggered, message enters from here. Okay, so after that, cache scope determines whether the message payload is non-repeatable. That is it a repeatable one or non-repeatable. Okay, that did that payload arrived previously or not. Okay, if that payload is the unique one, in that case cache scope generates a key using a SHA algorithm, guys. Okay, if you have not configured any custom caching strategies, if you have used if you have selected the default caching strategy, in that case it generates a SHA key using SHA algorithm to uniquely identify each and every request. Okay, so this is how the key looks like, guys. It generates a unique key for that particular message payload. So if this cache scopes receives that same message payload next time, so with the help of this key, cache will determine that this key is already there. We not need to process this request again and again. Just pick the data from the cache memory and send it to the client who is requesting the data. Okay, so guys, that's how this it works. Okay, moving on to the fourth point. So guys, it's I have already explained previously. So guys, the cache scope compares the newly generated key to the cached responses that has previously processed. Okay, and saves it in the object store. If you have configured any object store, it will save it there. If you have didn't configure any object store, so in memory object store it will save it. But guys, it is preferable to use object store because object store will give you more control over the caching mechanism. You can set your expiration time, how many keys you want to store. Okay, so it gives you more power to control the caching mechanism. Okay, so guys, that's how it works. Okay, let me go to the Anypoint Studio and show you, okay, in a complete way how it is processing the message. Okay, how you can configure it, how we receive the response. So everything I'm going to cover in the Anypoint Studio. Okay, so guys, let's get started with the practical use cases. So guys, as you can see, these are the 4 use cases I have configured. Okay, so one by one I will trigger each and every flow and show you how it works. Okay, so guys, this first flow is without cache scope. Okay, so I will deploy my app and make you familiar with the cache scope with the help of these use cases which I have designed. So guys, the application has been deployed. Okay, but before triggering this flow, let me show you the configurations. So guys, this is the listener I have configured. This is the endpoint. I'm hitting this listener at localhost port 8081 protocol HTTP. Okay, and this is the variable I'm using to store the ID. Okay, ID of that particular user who is requesting his personal details from a server. Okay, so this is the server, guys. This is the logger, which is just logging a log entry before hitting the server. And from this server, this is the server host name. We are requesting that user data with the help of the ID which a user is passing here. Okay, so we are passing it as a query param. You can see. Okay, once it got the data, this flow will be completed, guys. So this is a normal flow without caching. Okay, so first I will trigger this flow, show you how the flow works without caching. Okay, so I will trigger this flow. So as you can see, we have got the request. Okay, it is now hitting the server. Next, it got the response. You can see. Okay, George, and this is the first name, last name. Okay, and our request is completed. Again, I will hit this request from Postman now. Again, it is hitting that server, guys. That's for that same request. It is again hitting that server to fetch those details. Again, I will hit. So guys, again it is calling that server to fetch that same data, that same ID, which is 1. Okay, and this time also we got the same response. You can see George, last name Bluth. So guys, to avoid this thing, to avoid calling that server again and again for the same type of requests, for the duplicate request, we use cache scope, guys. Okay, so in these kind of cases, this cache scope will be very helpful. So in the next flow, I have configured this cache scope. You can see. Okay. So guys, in you can drag it from the palette. Basically, oh sorry, we need to write cache. So guys, you just need to simply drag it and drop it like this. And you can put any request components, any server calls which you have configured into this, like this, simply. And then you can just click on this and start configuring it. Because I have already configured, so I will not touch anything here. Okay, so guys, it's the same kind of flow, only the endpoint change. This time it is a second use case, so UC2 endpoint is there. This is the ID. It is storing that same ID which I am passing from here. Okay, so guys, this is the configuration I'm doing. So I'm using a default caching strategy basically. So guys, what I showed you previously in the presentation, if we are using default caching strategy, so with the help of SHA algorithm, it will generate a unique key based on the duplicate request it is based on the request it is getting. If it receives that same request next time, it will use that key and determine that did it receive that same request previously or not. So that key acts like to uniquely identify each and every request. And that key is generated with the help of SHA algorithm, which is a part of default caching strategy. Okay guys, so let me trigger this flow and show you how it works with cache scope having default caching strategy. So if I trigger this, let me change the endpoint name. Okay, the flow has been triggered having default caching strategy. If I click next, it is hitting that server now. Okay, because it's a kind of new request to this cache scope, because it didn't receive that request previously, because we didn't call this flow previously. So that's why it is calling this server now. Okay, it got the response. That's first name George, last name Bluth. If we click next, so our flow is completed successfully and we got the response. Guys, now we will hit the same request again to this flow and we will see. If we click next, so this time it will not call the server because previously it generated the SHA key for that particular request, which will uniquely identify that request from others. So because this request is same again, so it is saying that keys, hey, this request is same. So for same request, for this request, we have this key already stored in the cache memory. So we not need to call this server again. Okay, so guys, it will return that same response which it has stored previously. See, it is not calling that server now because it is already stored in the memory. Okay, so guys, that's how this cache works. If I again hit, see, it is not hitting that server. So guys, that's how this caching works, cache scope works. So guys, this was with the default caching strategy. Let's say you want to configure your own custom strategy. Okay, because in the default caching strategy, it generates a key with the help of SHA algorithm, which uniquely identify each and every request. But let's say we want to configure some custom caching strategy, which will uniquely identify the payload based on some parameters. Let's say based on the ID. So that also you can do, guys. So that part, that use case I've configured in the next flow. Let's move to the next flow and understand that. So guys, in this case, I have configured that caching strategy. If I click on edit, you can see I have added wheres.id to uniquely identify each and every request. Previously it was default. So because it was default previously, it generates SHA key using SHA algorithm. And this object store was also not there. I will not keep this for now and show you in the next use case how object store works. Okay, so guys, previously it was default. It generates key using SHA algorithm, which will uniquely identify the request from each other. But this time I am passing one custom caching strategy. I have configured one custom caching strategy in which I have passed key expression as wheres.id, ID of that particular user, which will uniquely identify each request from each other. Okay, so I will click on OK. I will save it. Okay, and I will trigger this flow now. And the listener endpoint is UC3. It's a same kind of flow, guys. Having ID configured, having logs. Okay, end log within cache scope log. Okay, so guys, let me trigger this flow. I think my application is already deployed. Okay, so this time the endpoint is UC3 and ID is 1. So guys, you can see I have triggered the request. Okay, and we got the request having this same ID as 1. Okay, so if we click next, so guys, the first time it is hitting the server. Okay, it will fetch the response from there for the same ID as 1. So we got the response, guys, having first name as George and last name as Plath. And next. Okay, but this time we have, because we have configured the custom caching strategy for that particular ID. So next time if we will hit the same payload with that particular ID, so in that case, guys, it will consider it as a duplicate one because that ID has already triggered previously. Okay, so from cache memory it will pick the response and send it to us. Okay, apologies guys, I think I have configured wheres.small id, but the variable name is id. Let me trigger this flow again. I think I have saved it and my application is deployed. Okay, let me trigger this flow again. So guys, our flow has been triggered. Okay, so similarly we will save the id. Okay, let me click next. So because we have configured custom caching strategy for this particular ID, which will uniquely identify each and every user from each other. So first time it will save it. Okay, it is calling the server because it didn't receive that request previously. Okay, so we got the same response, George Bluth. If we click next, okay, now again if I hit this flow having same ID, so this time guys it didn't call that server. Okay, because that ID is stored now in the cache memory. Okay, so that's why it didn't call that server. Okay, and proceeds to the next component without calling that server. So this time also we got the same response. Let me click next. Okay, you can see. So guys, this was the use case having a cache strategy. Okay, without object store, where key expression we have configured as ID. So guys, now in the next use case we will see what if we want to configure an object store, because it's a best practice recommended by Mulesoft to use object store, because object store will give you more control over the caching mechanism which we are doing. Okay, because you can configure maximum entries, maximum number of keys you want to store. Okay, what will be the expiration interval of those keys, those unique keys which you have stored, which will identify each request from each other. So all those configurations you can do in the object store. So guys, it gives you more control over the caching basically. So it's always a best practice to configure object store. If you do not configure object store, by default or whatever caching it has, it will use that, and you cannot set any expiration, you cannot set any number of keys you want to cache. Okay, so that's how it is helpful. Okay, and I have selected it as persistent, so because even if application stops or crashed, it will continue from where it left, but that is not in case of the default caching. So that's what the benefit it offers, guys. So I will click OK. So expiration interval I have kept as 60 seconds. So after 60 seconds, those unique keys, those unique IDs which will uniquely identify each request from each other will be expired. Okay, after 60 seconds. So how we will get to know that they are expired? So guys, for that I have configured one scheduler flow. So this is the one. Okay, so after every 10 seconds this flow will be triggered, and it will log the payload, that what are the keys it has. So guys, after 60 seconds we will see does it contain any keys. Okay, so we will get to know whether the keys are expired or not with the help of this flow. Okay, because it will log the keys after every 10 seconds. Okay, so we will get to know each time that are we getting that keys or not. Okay, so guys, this is our last use case. Okay, caching strategy, custom caching strategy with object store. Okay, and the endpoint is UC4. Flow is similar to that of the previous ones. I have ID, I have loggers, I'm hitting that same request. Okay, this is the host. Okay, so guys, let me trigger this flow and show you. We change the endpoint name. If I click send, so you can see I have triggered the flow. If I click next, so because it's the first time we are hitting this request, so it stores that particular ID in the caches. Okay, it will hit the server. We got the response, the same response, George. Okay, if I click next, okay, so guys, but you can see we have stored that key in the object store this time. You can see that ID, that key we have stored in the object store this time, that same ID which we have passed. Okay, you can see. So after 60 seconds this key will expire. Okay, okay, let's see will it expire or not. Okay, so guys, it has expired. You can see we are not getting that key now. Okay, we are not getting that key now because it has expired based on the expiration interval which we have set in the object store. Okay, so guys, that's how it works. Okay, so let me trigger this request again with same ID. Now it will call that server because the key has expired. You can see because that key has expired. Okay, but let's say if I hit this with a different ID, let's say 2, because 2 is a unique ID. It's not available in the cache scope, so it will call that server first. Okay, so this time we will get 2 keys in the object store. See, previously we have called it using the one ID as 1, and secondly we have called it with ID as 2. So both IDs are stored in the object store, and object store logs it. Object store flow logs it, the flow which I showed you here. So it is logging it after every time interval which I have configured. So after a few seconds it will expire, guys. Okay, based on the expiration interval which I have set in the object store. Let's wait. So guys, you can see it has expired now. We are not getting that keys. Okay, so if we hit this flow again, it will again call that server. See, it is again calling it. Now again it is stored in the object store. This ID as a 2 is stored in the object store. If we call this flow again now, it will not call that server. See. Okay, so guys, I hope you understood everything about this session on cache scope. If you have any queries, if you have any doubts, you can comment us. You can send your queries on the email. Okay, we'll try to resolve your queries as soon as possible. Okay, so guys, in the next session, we will cover about async scope. Okay, so guys, thanks everyone. Thanks for watching this session. See you soon. Bye.